All right, good morning and welcome back to Math 104. We are going to continue in our Unit 1 notes. We left off on page 14. Now, what you all had as a task over the weekend, besides, obviously watching the live stream video, either at that time or at a later date, but you also were responsible for trying your hand at problems A through F on pages 14 through 15. So that's actually what I'd like to start off with. What I'll do is I'll run through these problems. So you should be looking at your own work, and what we'll be doing is verifying that process and seeing how you did. And then of course I'll check in right after and see how it went, like if you have any questions, things like that. So hold off questions till we get through part F, and then we'll look at that together, okay? Let's check it out. So we left off on a general procedure for factoring a polynomial. Essentially, what does it look like if you combine all these rules and you're not explicitly told, hey, use AC grouping, or hey, use U substitution. So I wanted to look at several different problems, just kind of like a combination of all of these. As a little side note, do you see how I provided here a factoring summary? This is actually something you may want to jot down on like a formula page if you keep one, or you can actually write the formulas and then their factor form on index cards so that you can actually practice and make sure that you're understanding all of these styles, okay? Perfect. Part A, we have x to the fourth minus 81. Immediately, I'm going to notice that this is the difference of two perfect squares. What I also like to do is write down the form I'm going to use when I factor, so the difference of two squares. And again, even if you did do all the work, if you didn't name them, that might be a really good strategy. So I would advise you go ahead and throw notes over the work that you already did, including write down your factoring techniques. So we understand that this is definitely the difference of two squares. So immediately we go into, well, I know how to factor the difference of two squares. I have that here. So if I had a squared minus b squared, that would factor into a minus b times a plus b, or vice versa. So when I think about breaking down x to the fourth, right, into a quantity multiplied by itself, I would say, oh, that's definitely x squared times x squared. I know my signs must be opposite, positive and negative, because consider we're trying to get a negative 81 when we multiply these two numbers. And we know that's going to be when you take a positive 9 and you multiply it by a negative 9. If you had this first step, that is brilliant. That is your factored form, but it's actually not complete. Keep in mind that when you factor, you want to factor completely, not just part of the way. So we look inside each of these factors and we determine, can we go further? I want you to notice x squared plus 9 has this form here, which we notice is not factorable. So we're going to leave x squared plus 9 exactly as is. But then I'm going to look at x squared minus 9. And then I'm going to notice, wait a second, this is again the difference of two squares, because x times x gives you x squared. And we know that 3 times 3 gives you 9. These are perfect squares. So we're going to go ahead and break that down as x plus 3, x minus 3. And then we're going to call it a day, because that is the complete factored form for x to the fourth minus 81. Check. As always, if you were to do a check, I would advise you to do the following. Would you take a look at the screen for one moment? If you were going to do a check, I strongly recommend that you multiply these two first. Multiply these quantities first. Once you have these multiplied, you'll then distribute with the x squared plus 9. So it becomes the line above. So essentially what you want to do as you check is try to retrace your steps. If I multiplied x plus 3 times x minus 3, I'll get x squared minus 9. And which is great because that was the step before. And then you can multiply these two and make sure you get this step before. So always retrace your steps as you're checking. Cool. Let's take a look at part B. For part B, notice here 4x squared minus 4x minus 24. Even if you like closed your eyes and someone read that out loud to you, you would say, I have a GCF. I can hear it. It's a 4. I can definitely factor out 4. And you're going to start by factoring out that GCF from all three terms. When you take out that 4, that's going to leave you with x squared minus x minus 6. And we learned that in order to ensure that the GCF doesn't distract us, we're just going to hold on to it. It's also a reminder that that needs to be part of my answer. So I look and I say to myself, well, x squared minus x minus 6, I notice that this has the, it's a trinomial where it has the form where my a is equal to 1. So guess what? I'm going to use trial and error. I like trial and error for trinomials whose leading coefficient is equal to 1 because it just makes life so much easier. You still go through that process of a times c. So 1 times -6 is -6. And we want factors of -6 that combine to give us -1. Remember, your goal is to identify the factors of AC that combine to give you B, right? In the cheat sheet, in this little chart here, it says find pair of factors with product equal to C and sum equal to B. That's the same exact idea. The reason this doesn't say AC is because we know that A is equal to 1. So our goal is to find factors such that the combination of the two will give me a -1. That's my goal. We want to find where B is equal to -1. Now, because my B is -1, that means the larger factor has to be negative. So we'll say, okay, well, 1 minus 6 is -5. That's not going to work. 2 minus 3 is a -1. That one works. So I'm going to go ahead and highlight the two factors that I found. Those are 2 and -3. And then I'm going to go ahead and write my factored form. So let's write our sets of parentheses and we're just going to fill it in. That's the beauty of trial and error. Recall that in order to make x squared, you're simply going to multiply x times x. And then in order to make a -6, we found that we're going to use 2 times -3. So it's a +2 and a -3. We're then going to, no worries, Christina, thank you so much. We're then going to lift up our finger and show that we have already factored a GCF, which is 4. Bring that right down and you're done. Okay, as always, double check. Make sure that you factored this correctly. There's no reason for you to not be sure if you factored correctly, especially when all you have to do is distribute. Remember, retrace your steps. So you should distribute these two first to ensure that you get x squared minus x minus 6, then multiply by 4 to again retrace your steps. All right, let's turn the page and look at part C. For part C, we have 2x squared plus 7x minus 15. Right off the bat, I noticed there's no GCF, but it is a trinomial whose leading coefficient is bigger than 1. So right away, that says to me, I need AC grouping. All right, so we are going to go through the process of AC grouping. We're going to start by taking A, which is 2, multiplying it by -15 because that's C. That's going to give me -30. I want factors of -30 that combine to give me a +7. So we could list out the factors. This part is completely optional. I'm just going to leave this up to you in terms of whether or not this is something that's helpful, listing all these factors. But notice it took me less than 20 seconds to do that. So keep in mind that that's an option. We know that our signs have to be different and that the larger factor must be positive. So the smaller factor in each case is going to be negative. If we take a look at each combination, this is going to give me 29. That's not a 7. This will give me 13. That's not a 7. This one will give me a 7. Voila. I just found the two factors that I'm going to use. AC grouping is not trial and error. With AC grouping, recognize that we took care of the AC part, but we now have to take care of the grouping part. What that implies is that you need 4 terms in order to group, but you only have 3. So as a reminder, as a refresher, we say to ourselves, well, I'm simply going to rewrite the polynomial because I know that -3 plus 10 is 7. So that means I'm going to replace my 7 here with these 2 factors. So I get 2x squared minus 3x plus 10x minus 15. It's the exact same polynomial, just expressed differently, obviously. And again, hopefully this is me validating your work, because this work you should have done over the weekend. So hopefully this is proving you correct. That's the goal. Out of the first 2 terms, we're going to factor out an x. That leaves you with 2x minus 3. No matter what, you're always going to bring that middle sign down, that plus. It's nice because it follows that same pattern every single time. Let's bring down that plus sign. Out of 10x minus 15, we're going to factor out a 5. If we factor out a 5, we're left with 2x plus 3. Notice that in this line, we have a binomial factor that repeats itself, aka this now becomes our GCF. So we're going to factor out the 2x minus 3 from each term. If we take 2x minus 3 out of each term, you're left with x plus 5. And there you have it. As always, make sure you distribute to verify that you have the original polynomial. Good. Taking a look at part D, 2x cubed plus 128. Immediately I start to think, whoa, even numbers, right? They're both even. So my first step of factoring, no matter what, is always GCF, GCF. Like I say like that because I really want you to remember that. So I'm going to take out a 2. They're both even. So I'm definitely able to factor out that 2. I'm going to cover it up so that it's not distracting. And then I notice, aha, okay, x to the 3rd power this time. And 64, okay, I know that 4 times 4 times 4 is in fact 64. So this is the sum of 2 cubes. Because this is the sum of 2 cubes, we definitely want to write down the factored form, okay? Hands down all the time. If you haven't memorized it by now, that's okay. Don't beat yourself up. Just keep practicing and it'll come to you very naturally. So the sum of 2 cubes formula is a plus b, right? This is going to be the same sign. Then we have a squared, and then it's going to be the opposite sign no matter what. So it's going to be the same, then opposite, and then always positive. So remember how we mentioned in the live stream the acronym SOAP? Same, opposite, always positive. SOAP. Next, we need to figure out what A and B are. So the first thing I'm going to do is I'm going to say, well, I know that we're taking the x, and that's what we're multiplying by itself 3 times, x times x times x. And then in order to get 64, you take a 4 and you multiply it by itself 3 times, 4 times 4 times 4. So I've just figured out what my A is and what my B is. And again, use that highlighter, use whatever colors to identify the steps that you're taking and where you want to go with that, okay? Everywhere we see an A, we'll replace with an X. Everywhere we see a B, we're going to replace with a 4. So I'm just going to move through this. A is x, and obviously A is squared, so it becomes x squared minus A is x, B is 4. But if you have x and a 4, that means that becomes 4x. Don't write x4. That's just weird, okay? It's not like a car model. So, and then plus, then we have b squared. B is 4. 4 squared is 16. Now we would be done, except I'm covering a GCF. So all we're going to do is we're going to write the 2 directly in front, and we're done. That is complete. That is our factored form. We have two more, then I will take any and all questions, okay? Two more. We're almost there. For part E, we have a 4-term polynomial. One of the first things I personally will look for is if I somehow have a perfect square, trinomial here as part of like this entire expression. Immediately though, I also notice it ends in a plus 48. So in order for us to actually effectively use a perfect square trinomial factor in a 4-term polynomial, is that this would have to be minus and then some sort of perfect square, right? But that's not the case. So we do not have that here. Instead, because we have a 4-term polynomial, we're just going to use the basic factoring by grouping. That's all. Don't overthink it. Whenever you have 4 terms, try this out. If it doesn't work, maybe there's something else going on. So in this case, we're definitely just going to be factoring by grouping. That means look at the first 2 terms, look at the last 2 terms. Out of my first 2 terms, I'm going to notice here that I actually have a GCF of x to the 4th. Remember, when you're looking at your variables, take the smaller power, right? Between a 5 and a 4, take the 4, because that's the most you can factor out of both. So if I factor out x to the 4th, I'm left with 5x minus 3. No matter what, we're always going to bring down that sign. So we have a minus here. But consider that when we actually physically bring down that minus, that means we're factoring out a negative. When you look at 80x and then the 48, let me show you a trick. I'm going to show you a trick because I don't want you to sit wondering what your GCF is. Do you see how in this parentheses you were left with 5x minus 3? The other set of parentheses should also be a 5x minus 3. So what that means to me is that I can take a number out of each such that I'll be left with a 5 when I divide 80 by it, and I'll be left with a 3 when I divide 48 by it. So immediately, if I want to figure that out, I'm just going to take 80 and divide it by 5. Oh, I get 16. I'm going to take 48 and I'm going to divide it by 3. I get 16. I just figured out my GCF. If I factor out that negative 16, like I said, you're going to be left with 5x minus 3. You don't even have to like overthink that. Always check. Negative 16 times 5x does give you a negative 80x, and then negative 16 times a negative 3 is in fact positive 48. Just a little trick that you can use, especially since you know they have to be the same. So we have the same binomial, 5x minus 3, which means that's our GCF. So we're going to factor out 5x minus 3, and that leaves me with x to the 4th minus 16. Well, I'm not done yet because my eyes are drawn to x to the 4th minus 16. Looking at this particular set of parentheses, I know that I'm going to use the difference of 2 squares, believe it or not. So I'm going to go through that process. So we have 5x minus 3. And then I know that if I want to break down x to the 4th minus 16 to squares, I understand that that means x squared times x squared gives us x to the 4th. And that also means that 4 times 4 gives us 16. So we have x squared plus 4 and then x squared minus 4. There's your difference of 2 squares. But we're still not done. We are still not finished revealing the final answer. Hopefully you saw that there was way more involved in this problem. Always analyze again and again and again. Please, always analyze your answer, okay? For instance, we know we're done here. 5x minus 3 can't be broken down any further. X squared plus 4 can't be broken down any further. We do not have the sum of 2 squares. That doesn't exist. But then notice we have x squared minus 4. Again, the difference of 2 squares. So believe it or not, here's your final answer. We've got 5x minus 3. we've got x squared plus 4. And then we break down x squared minus 4. This is the difference of two squares, so that becomes x plus 2, and then x minus 2. Now we have our complete answer. Pretty crazy, right? Lots and lots of layers. I like this problem a lot because it forces you to be analytical and it forces you to push yourself. Don't just end because you think that's it. Make sure you're checking your work. Make sure you're verifying if you in fact are done factoring. Last one before I check in, and that is part F. So we do have another 4-term polynomial, and we might say, hey, let's just do factoring by grouping, but there's a couple things going on. Do you see here how these are like terms? That's odd. When you have a polynomial like this presented to you where two of your terms are like, but you're being asked to factor, what this should kind of do to you mentally is say, oh, hold on, I might have something specific going on here, right? And without trying to play too many games, I hope that you see that we actually have a perfect square trinomial here. So I'm going to just look at our first 3 terms. I'm going to note here that that is a perfect square trinomial. So perfect square trinomial. I'm going to double check mentally that that's a perfect square trinomial. We know that 4x squared would break down into 2x times 2x. We know that 49 would break down into 7 times 7. What the signs here tell us is that our signs are going to be the same, but they're both going to be negative. Okay, so let's check this out. So I would have 2x minus 7 times 2x minus 7 if I factored this perfect square trinomial out correctly. Do a check, 4x squared, negative 14x, negative 14x. Yep, that gives me my negative 28x, and then plus 49. Recall that when we dealt with perfect square trinomials, we always rewrote the expression as the square of the binomial. The square of the binomial. Because now we get to use our last technique, the one that we were a little, I guess a little bit reluctant to kind of dive into because it's a little bit more complicated, but use substitution. So not only are we going to factor by using the formula for the difference of two squares, but we're actually going to use the u substitution. So we're going to call u 2x minus 7. If u is 2x minus 7, my polynomial becomes u squared minus 100. That's super familiar. I can factor the difference of two squares. That would be super easy. That's no big deal. U squared minus 100. Okay, let's factor it. That becomes u plus 10 and u minus 10. Right, no big deal. 10 times 10 gives you 100. U times u gives you u squared. The last thing we do is put u back. So we are going to replace the 2x minus 7 for u. So 2x minus 7, but then notice I have a plus 10. U is 2x minus 7, and then I have a minus 10. Everyone, you cannot leave your answer like this. You can't. You have to combine like terms. When you some of you were doing your homework for the u substitution in unit 1, and that very first problem was write out your work on a separate sheet of paper and then type your answers. Well, some of you, unfortunately, when you typed your answer in there, you didn't combine like terms, and that's a mistake. you want to look at the the expression that you have and clean that up. If you have to distribute to drop parentheses inside, do it, but please clean it up. You can't just leave it like that. So for instance, when I see my answer here, I'm not done because -7 plus 10 gives us a +3. And then here, I'm not done either because at 2x, we get -7 minus 10, that's a -17. Now I am finished. Now I have factored completely. Awesome. Okay, I'm ready for you. What questions do you have for me on A through F? Questions, concerns, comments, what's on your mind? How did it go? Talk to me.
Sorry.
Oh, I was just wondering, I forgot to write it down, but what is A and P in SOAP?
Is say A and B and C? Oh,
No, A and P in SOAP.
Yes. So when we look at that idea of SOAP, I'm going to write that down. SOAP. So this just means same sign. So I'm just going to write same. Then the next sign's always going to be the opposite. So I'm just going to write op. And then the third sign is always, wow, I wrote AB. Hold on, my brain's not working. That's why I have this. Sorry.
Bless you.
Thank you. Then the last one's AP, and that's because always positive. Oh my God, I'm so sorry.
Bless you.
Thank you. So same sign, opposite sign. The last one's always positive no matter what. That kind of speaks to our chart. Take a look here at these two formulas. So we have a to the third minus b to the third. That's a difference of 2 cubes. And check this out. Same sign, opposite, always positive. So the sum of 2 cubes, same sign, then opposite, then always positive. Does it help to kind of look at it like that? Yay, nay, maybe? Who's next?
So like in E, when we get down to like the last part, where the x plus 2 times the x minus 2.
Yeah.
Dang. Oh, I was saying like the x squared plus 4. Why didn't we make that just like the x plus 2 and the x minus 2? I don't know.
Because x squared plus 4 is not actually factorable. So I have here, just as kind of like a little cheat sheet thing, if you ever had this, so for example, you can even write it down like x squared plus 4 is a really good example. These are both perfect squares, but because this is x squared plus 4, it's actually not factorable. Tiana, later in this class, we're going to learn how to factor that. It's just not factorable using real numbers. So that's why we leave it. By the way, if you took x squared plus 4, and let's say that you factored it as, I'm just going to write this down to prove it to you. Let's say that you factored it as x plus 2. If we did x minus 2 right away, you know that you're going to end up with x squared minus 4. And I'm just going to prove that to you real quick. Notice these two cancel, and you're left with x squared minus 4, which is not what we started with. And then you may think, okay, wait, let me go back to the drawing board. What if I do x plus 2 and then x plus 2, right? Because you figure that's how you get a positive. Well, let me distribute for you. If you check it, we get x squared plus 2x plus 2x. Do you see the problem already?
Mm-hmm.
These don't cancel. So using real numbers, we're not actually able to factor that.
Okay.
For your reference, don't hate me, but I want you to see it. For your reference, this actually factors into the following. Don't hate me, please. And yes, those are I's. So when we talk about the complex number system, we're going to refer to something called imaginary numbers. And that is what helps us factor a polynomial like that. Okay. So that's what it would look like. I know it's crazy. I'm going to put it away. Okay, it's gone. But just keep that in mind. Sum of two squares, you can't factor that.
Okay.
Beautiful. More questions, more.
So what you just did is, so did you just explain why the sum of two squares doesn't exist? Is that what you just did?
Yes, that's absolutely correct. So you can only factor it using the complex number system. So we have to use imaginary numbers to factor something like this. There's a whole slew of reasons why, and we'll dive into that when we talk about the fact that I is equal to the square root of a -1. Okay, so we'll get there way later in this class. But this is going to be fun, actually. It's a really fun section.
Yeah, because that's I thought by the difference of two squares you could do it that way or something. I'm very confused by that.
Yeah, so you're right. But James, did you hear what you said? You said the difference of two squares. Difference is subtraction. So as long as you're only focused on the difference of two squares, beautiful. That is exactly how you would factor it. Notice this is the sum of two squares. That's the problem.
Right. Okay.
Beautiful. Beautiful. Don't factor the sum of two squares because it's not factorable. Very nice. Remember, this cheat sheet is going to be huge. Keep that in mind. Just keep it handy somewhere. And then whatever extra notes you want, go ahead and throw that in there. What other questions do you have?
I don't know if I'm overcomplicating this, but in C, I would have done 2x squared plus 10 minus 3 minus 15. Or like I had it flipped around.
Yeah, cool. That works.
It's this, I can do that. I don't have to do.
You could totally do that. And actually, you're right. I didn't think of flipping it, but you're totally right. The 10 would go better with a 2, and the 3 would go better with the 15. But notice, Phil, that even though you wrote 2x squared plus 10x minus 3x, and I always like showing you. Let me just do it. So when you had 2x squared plus 10x minus 3x minus 15, so we're essentially just flipping these two terms, like the order, we're going to end up with the same thing. So I like the fact that you group these together because they have a little bit more in common, which is nice. Notice with the second two, you took out a factor of -3, you're left with x plus 5. And you see how this still works?
Yeah.
Still actually approaching the same answer, even though we flipped the order of the two inner terms. So our answer is identical. And Phil, that will work every time. So the order of those two inner terms, however you see fit, whatever your style is.
Good to know. Thank you.
You're very welcome. Excellent question. And just to prove it, look, 2x minus 3x was 5. X was 5, 2x minus 3, same thing. Beautiful. Last question. Who wants to take it? Last question. All right, it looks like we're doing pretty good. Let's go ahead and turn the page. So what we're actually going to get into, and you're probably thinking, oh my God, I am not done factoring. And I am so sorry, but you won't be done factoring for 4 more weeks. I am not even kidding you. You're going to factor for forever. Okay. Luckily, we only have 11 more classes left. So anyways, don't sweat it. Just embrace it, become masters of it. The section we're about to do is we're going to learn how to actually solve. You actually did this in 098. You solved quadratic equations by using factoring. You did this last semester. So it's just a continuation of that idea. The reason we see it again is because we just saw a heck of a lot more factoring techniques that we have to consider when we're using factoring to solve quadratic equations. So let's just check it out. If you have any questions in the meantime, just let me know. I do see there was a, okay. As a reminder for the homework, your first assignment, I believe, is due tonight by midnight. Didn't we all agree Monday?
Yes.
We did, right? Okay.
Yeah, the first one.
Tonight at midnight.
Okay,
The
beautiful.
next one's due Friday, I think.
Yes, yes. So the first assignment is due tonight by midnight, so you still have time to complete it. Your second one is due by Friday midnight. I think that's only 4 problems. If you're ever late with a homework assignment, or let's say you forgot a homework assignment, just let me know. Just talk to me. Within reason, I will be able to say, yeah, here's another shot. There's a difference between, can I get another shot now, and can I get another shot for 5 more assignments? Like, those are huge. There's a hugely different. So I don't want you to abuse that. You know, make sure that you're on top of all the things you have to do. But I do know life gets in the way. So just talk to me. If you miss an assignment, let me know. But you haven't yet. It's not due yet. Okay. All right. Let's check out the notes. Solving quadratic equations. First off, we know a quadratic equation is of the form ax squared plus bx plus c. Notice it's equal to 0. So this is the standard form. I'm going to highlight this because it's incredibly important that you remember that in order to even begin to factor, this has to be equal to 0. So the moral of the story, equal to 0. That's huge. Sometimes you have to rewrite the polynomial so that it is equal to 0. Having said that, when we factor to solve, we use something called the 0 factor property. All that means is that if you have 2 factors such that when you multiply them, it gives you a 0, that means one or the other has to be 0, right? 0 times a number is 0. A number times 0 is 0. So all it says is we need to take each of those factors, set them equal to 0, and then solve. That'll give us our solutions. Let me show you. Switching back. Notice the first one says solve the equation x plus 6 times x minus 1 is equal to 0. The beauty of this particular problem is I factored it for you. Okay, I factored this polynomial for you, and this is what you had left. So what you end up doing by applying the 0 factor property is you take each factor containing a variable. X plus 6 is a factor and it contains a variable. X minus 1 is a factor and it contains a variable. Set them each equal to 0 and you solve. That's it. So we're going to go ahead and subtract the 6, and we see that x is equal to -6. And then to solve x minus 1 equals 0, we're going to add the 1, and we find that x is equal to 1. So when we write our solution, do you see this blank here and it says solution set? We're going to go ahead and use braces. Think back to set builder notation. With set builder notation, we needed braces. Do you see these little squiggly lines? They're braces, like in your teeth. Okay, so we have a set of braces and our 2 solutions are -6 and 1. So we're simply going to list the solutions in a set. And there's your answer. Voila, you're done. You could even write x equals if you wanted. I'm totally cool with you just using braces and then -6 -1, or excuse me, -6 +1.
And it always goes from left to right, right?
So technically, because this is just a set, you're just listing your answers. You'll never get an answer wrong if you don't put them in order, right? As long as your solutions are just listed in that set, that's good enough. The difference is if you had something like interval notation, that's way different. But here we're not solving an inequality. And we're not writing our answer in interval notation, which is, you're correct, left to right, lowest to greatest or smallest to greatest. That's different. So here we're just listing our answers in braces because it's a set. Okay, so no worries on that. If you want, write it from smallest number to largest number every time, just so that you maintain good habits. Very cool. Now, I want to show you this first box because I've seen students do this. So for instance, imagine that I presented to you x minus 3 times x minus 4 equals 6. Well, hopefully right away, you're noticing that this is equal to 6 and it's not equal to 0, which is a problem. When we started talking about solving, we learned that you always have to have it equal to 0. But here we have it equal to 6. It is completely, 1000% incorrect if you took each factor and said, oh, I'll just set it equal to 6 instead. No, please don't ever do that. It does not work that way. What you would do to fix a problem like this, does anyone know? How might you fix a problem like this?
Subtract 6, put it over on the other side.
Yeah, you would. So for instance, we had x minus 3x minus 4, and it's equal to 6. You said, well, we would fix that by bringing the 6 over. Now, the only issue here is that when I bring that 6 over, man, does this look ugly. This looks hideous. It looks disgusting. All this tells you, everyone, is that you're just going to distribute to open it up. So as a quick, showing of what you would do here, you would say, okay, that gives me x squared. I would get negative 4x, negative 3x, positive 12, minus 6, right? Then you would just combine and combine. So we'd have x squared minus 7x plus 6 is equal to 0. Then you would factor this expression and then solve. All right, that's the flow you would take, because the important piece here is that your polynomial must be equal to 0. That's going to help you to solve using factoring. We have other techniques, but we don't learn those just yet. We'll see a bunch of other techniques later. Very cool. Notice over here, again, this is incorrect. We do have that it's equal to 0. Totally true. But notice what this person did. They said, okay, let's take the 2x minus 1 set equal to 0. Let's take the 3x plus 5 set equal to 0. And then let's take a minus 6x and set equal to 0. That's a huge problem. Minus 6x is not a factor, it's a term. It is a term. So what you would end up having to do is you would have to distribute first, combine like terms, then factor. So this is not completely factored. This is not in factored form. It is not, because you have 2x minus 1 times 3x plus 5 minus 6x. That's not factored form at all. Okay. Recall that when you look at polynomials in factored form, it looks like what we've been doing again and again and again and again. So factored form looks like this. Factored form looks like this, right? We don't have an additional term at the end. So that's why we have to be super careful. For this one, I'm going to say not equal to 0, just so that we have that in our notes. All right, cool. Let's actually apply this. So remember, set equal to 0, factor according to the number of terms, and then set each factor containing a variable equal to 0 and solve. And we could always check for mistakes by substituting back. All right, take a look at part A. We have 7x squared is equal to 56x. Shout out how you would set this equal to 0. What do you think? Shout it out.
subtract 56x.
Yes, I actually really like that you said that. Some of you might subtract the 7x squared. That's totally cool. Not a big deal. The only thing is your leading term would be negative. So just make sure you factor out that negative. But I actually prefer if you subtract the term with smaller degree. So we have 7x squared minus 56x is equal to 0. Someone else, what's the first step of factoring no matter what?
And the GCF.
Yes, GCF, GCF. That's your first step of factoring no matter what. So I'm looking at a 7x squared minus 56x. What's jumping out at you? Someone else. What's your GCF?
7x.
Yeah, 7x. Beautiful. So we're going to take that 7x out and just see what we're left with. Dividing each term by a 7x leaves me with x minus 8. Cool. Do you see how I can't factor anymore? I have x minus 8. That doesn't break down anymore. We're totally done. Now we're ready to apply the zero factor property. All that means is you're going to take each of your factors containing a variable set equal to 0. Your first factor is 7x. You heard the x, you heard the variable. So 7x gets set equal to 0. Your second factor is x minus 8. You heard the variable again. So x minus 8 gets set equal to 0. And now all we have to do is solve. For the first one, divide by 7. And voila, you get that x is 0. By the way, this is okay. It's not a big deal. That just means your function, your polynomial, goes through the origin. We'll talk at a later date about what that looks like, because guess what? We're going to end up having to graph these guys. Okay, we'll get there one step at a time. For our second equation, add 8. And so I see that my two answers are 0 and 8. Quick point that I want to make out. Your power is a 2. That's the biggest power you see. According to the fundamental theorem of algebra, your degree directly coincides with the number of solutions you'll have. If this were a 3, you'll end up with 3 solutions. If this were a 7, you'll end up with 7 solutions. Like, no joke. Okay, keep that in mind, something to think about as you do this. I will tell you that it is possible to have the same answer. So like, let's say you got x is 0, x is 8, and let's say you had a third solution and it was also x is 8. That's okay, right? That's okay if you have a double root or something like that. Just keep in mind, whatever your degree is, that coincides with the number of solutions. We have a blank here for our solution set. So let's just write it properly. Brace. And then I'm just going to write 0, 8. I'll put them in order. And that's it. I apologize if the squiggly lines are getting to you and you're just like, I hate writing these. I am sorry. Okay. What questions do you have on this page related to solving quadratic equations using factoring? Okay, take a quick look at this box down here while you think about any questions if you do have any. To progress, check out what they did. So we had 7x squared is equal to 56x. And then they said, what if we just divided by 7 first? That's actually okay. There's nothing wrong with this. So this process here is correct. Notice that when they have x squared is equal to 8x, that's when they'll bring the 8x over. And then that's when you factor and solve. So it's actually okay for them to have divided by the coefficient first. That's totally cool. What's not cool is the second expression. do you see here in the second expression, they said, how about we just divide by 7x so that it's real quick? This is incorrect. You cannot divide by the variable because you do not know if the variable is actually 0. Can you take your calculators for a moment and just punch in any number you want? Any number, doesn't matter. Just type that into your calculator. I'm going to do 59. Now I want you to divide that by 0. What does your calculator say?
Not a number.
Yours actually gives you the number back.
Oh, it said not a number right
Oh,
out.
not a number. Yeah, exactly. It gives you not a number, divide by 0, error, some sort of error message like error, error, crazy, right? We cannot divide by the variable because we do not know if it actually represents a 0. Now, the funny thing is with this particular problem, x was equal to 0 and x was equal to 8. So the rule of thumb here is when you're trying to solve, you're not dividing by the variable because we do not know if that actually represents a 0. When you divide, Shane, when you divide by 0, it's undefined. You never want to do that. Don't make that mistake, okay? So for general purposes, follow the flow, set it equal to 0, factor, set each factor equal to 0 and solve. Okay, that's going to be a great flow. We will learn how to use the square root property, which is actually pretty cool. We'll learn how to complete the square, and we'll learn about the quadratic formula. So those are other ways to solve quadratic equations. Okay, for now, keep that in mind. Set equal to 0, factor, solve if possible. Cool. Let's turn the page. 2x squared plus x is equal to 1. All right, what do you got? Someone tell me what might be the first step I would take.
Subtract 1.
Yeah, thank you, Melina. We're going to subtract the 1. And I really like the fact that you started there. I know you're probably thinking, well, what else would you do? I mean, I've seen some crazy stuff. I've seen people bring the 2x squared over and the x. It's so much easier just to bring the 1. We have a trinomial. Let's factor it. What technique should I use? Give me a name. You could do this.
AC?
Yeah, AC grouping, score. That is correct. AC grouping. You know, AC grouping is going to be great because it's a trinomial and your leading coefficient's bigger than 1. That's the hint here. So we go through the process. 2 times a -1, right? A times C. 2 times a -1 is a -2. I need factors that combine to give me a +1. So our only factors are 1 times 2. Obviously, my smaller number is going to be negative. -1 times 2 is a -2. -1 plus 2, well, that's a +1. So we found our 2 factors. Good. I'm going to go ahead and rewrite this trinomial as a 4-term polynomial because now we're trying to focus on grouping. And I'm going to use Phil's strategy. I'm going to put the 2 with the 2x squared, right? That just makes more sense. So I'm going to do 2x squared plus 2x, then minus 1x. So plus 2x, then minus 1x. And then we see here we've got -1 and then equals 0. We have 4 terms. Go ahead and factor by grouping. Hopefully you guys have a nice flow here. You're like, yeah. I know exactly what to do. I know what my GCF is. You'll factor that out. I want this part to be like the piece of cake for you. You know, I want you to see this and say, yeah, I got this down pat. That's my goal for you. If you're not quite there, not quite at the point where you're like, yeah, please practice, keep practicing. You have to, okay? You need to master this because otherwise what's coming up is going to really upset you because it's a ton of factoring. So we set each factor containing a variable equal to 0, and then we simply solve. I find here x is equal to -1. And then I find here, see how I brought the 1 over, and then I'm going to divide by 2. I find that x is equal to 1/2. So in terms of my solution set, we'll go ahead and write our braces. And I'm going to write down that my solutions are -1 and 1/2. All right. Very, very nice. I want you to go ahead and work on part C. I want you to think about the conversation we had when we started this section exactly, and think about how you would progress through part C. Give that a shot. I'll give you a couple minutes starting now. I'm going to reveal the first part here. So let's say that we know that it's not equal to 0, and that's a problem. And generally speaking, we would want to bring that 6x over. What if I start by distributing first? Right? So that gives me 5x times x, which is 5x squared. 5x times 2, which is 10x. -1 times x, which is -1x. -1 times 2, which is -2. And then I bring that 6x over. So let me just write equals 6x, and then I'm going to bring the 6x over. You see how I did that? So I drop the parentheses so that I can clean it up and bring the 6x over and combine it with its like terms. If you keep the expressions in parentheses, you can't do that. You won't be able to. So we distribute to drop parentheses. And now that leaves me with 5x squared. And then I've got 10x minus 1x minus 6x. Altogether, that ends up leaving me with a plus 3x minus 2, and then equals 0. That's how you would progress through the problem. Shane, yes, that is your goal, because it's, think about it as AC grouping. So AC to give you B. AC to give you B. Good. I'll give you another 60 seconds to finish this problem. Just 60 more seconds to finish this off. At this point, you'll just apply AC grouping, okay? 60 seconds to finish this off. I'm going to pause the recording for now. Okay, let's finish this off. So we've got AC grouping. A times C, 5 times -2, that's a -10. We want factors of -10 that combine to give us a +3. We know that's going to be 2 times 5. More specifically, we know that the 2 has to be negative and the 5 has to be positive. Double check, -2 times 5 is -10. -2 plus 5 is a +3. So that checks. We're going to take these two factors, a -2 and a +5, and we're going to replace the 3x with them. Now, again, using Phil's strategy, let's bring that 5 next to the 5x squared, because we'll see we have a lot more that we can factor out. This is not essential. You do not have to arrange them this way. I'm just going to, because we can see that there's more of a common factor if we do that. Out of your first two terms, we're going to factor out a 5x. That leaves you with x plus 1. Out of your second two terms, we're going to factor out a -2. That again leaves you with an x plus 1. And then all we have to do is take our common factor of x plus 1. We're going to factor that out, and we'll be left with x plus 1 times 5x minus 2. And then, of course, that's equal to 0. Now, once we have our factored form and it's set equal to 0, we want to then set each factor containing a variable equal to 0, and then we solve. So we're going to start with that first one. Let's subtract the 1. We get x is equal to -1. And then we have our second equation, which is 5x minus 2 is equal to 0. So we solve that. And then when we finish this, we find that x is equal to 2/5. So for our solution, we've got some braces here. And our answer is going to be -1, 2/5. Excellent work. I am hopeful that this is, you know, making more sense as we progress through this, and it becomes easier and easier. I do want to apologize that we did not take a break. As long as you're okay with it, I would like to continue through and just finish to 10:50 if that's okay. Are you all comfortable with that?
Yes.
Okay, okay. If you need a break, take it. Don't feel like you have to stay, but I do want to keep going because this is moving really, really, really well. Taking a look at part D, we have 8x to the third plus 22x squared minus 6x equals 0. Okay, so let's start with Summer. When you look at this particular polynomial, what's the first thing you would look for?
Other than the fact that it's already equal to 0?
Yes, which by the way is not anything to like, I want you all to notice that Summer said besides the fact that it's already equal to 0, that's huge. That is huge. And so that's awesome that she's already recognizing it's equal to 0. We all have to do the same thing. So yeah, Summer, what would be the first thing you do to factor?
I guess find GCF.
Yes, absolutely. So if you look at all three terms, what's jumping out at you?
The
degrees are going in order from highest to lowest.
They are. They're totally going in order from highest to lowest. What are you noticing that could come out of each of these?
A 2x.
Yes. Let's take out the 2x from these three terms. So if we factor out a 2x, that leaves us with 4x squared plus 11x minus 3 is equal to 0. Very, very nice. Please cover up the 2x. Jimmy, what factoring technique would I use for this? I've got 4x squared plus 11x minus 3. What technique should I use to factor this trinomial?
Can you wait? Can you do AC grouping with that?
Yes, thank you. We're exactly going to do that. Thank you. Okay, I'm going to move through this so we don't take too much time on using AC grouping because honestly, I want this to be second nature to you. Okay.
You'd be doing the 11 then, right? Because it's the highest.
Well, you still have to go through A times C. Right.
Oh, okay.
So, yeah.
Yeah.
So for instance,
Right.
Jimmy, we know A is 4 and C is -3.
Okay.
So we start by multiplying those two together. But you are right. Our goal
Gotcha,
is
okay.
11.
All right.
Okay. Your factors are 1 times 12. And guess what? We don't need to go further than that because we know that a -1 times 12 gives us -12 and -1 plus 12 gives us a positive 11. And that's exactly what we were looking for. We're going to use these two factors to replace our 11x. So we have 4x squared plus 12x minus 1x minus 3. I'm going to go ahead and group these. You're probably noticing that I'm not bringing down the 2x and I'm not bringing down the equals. I will, I promise. I just want to actually factor by using AC grouping. So out of the first two terms, I'm going to take out a 4x. That leaves me with x plus 3. Out of the last two terms, I'm going to factor out a -1. That leaves me again with x plus 3. So my final factored answer is x plus 3 times 4x minus 1. Don't forget that we're covering up the 2x. So we'll bring the 2x down in front. And then, of course, that's equal to 0. Princess, at this point, if I wanted to solve, what do I have to do here? What are my equations?
Why do you have a 4x in the second parenthesis?
So notice here, Dimitri, that when I factored using AC grouping, that I factored out a 4x from the first group, right?
Oh, yeah. No, I
Yes.
totally overlooked that.
That's okay. That's okay. That's why I'm happy to break that down. We bring that x plus 3 here and then the 4x.
Yeah, I got it confused with something else.
That's okay. That's okay. It's always better, and this goes to everyone, it's always better to clarify than to sit wondering, you know, what, how, who, where. So always clarify with me, okay? But yeah, Princess, so what are your equations to solve?
X plus 3 and 4x minus 1.
Okay, so we've got x plus 3, we'll set that equal to 0. We've got the 4x minus 1, we'll set that equal to 0. Anything else?
2x.
Yes, we're also going to set the 2x equal to 0. Your first factor, because it has a variable, your second factor, because it has a variable, and your third factor, because it has a variable. Also notice, look at your power. You have a power of 3. So you should have 3 solutions. This is to be expected. We'll divide by 2, we find that x is equal to 0. Subtract 3, we find that x is equal to -3. And we solve this last one. Divide by 4, and we get that x is equal to 1/4. And now we just have to list them. So in our solution set, or as our solution set, we've got -3, a 0, and a 1/4. And that's how you would write your answer. You're just literally listing them. Very nice. Can you all take a look at this box? Is this correct or not? Did they do anything wrong?
It's incorrect.
That's incorrect. That I agree with you. This is definitely incorrect. Can you tell me what they did wrong?
It's not supposed to be 4 numbers at the end. It's supposed to be 3. 'cause
Yes. Oh my God. I totally agree with you. You know this because the power is 3, so you're expecting only 3 answers. Yes. Thank you for saying that. Okay. So how would they fix their work? Like they jumped to the answer, so that's a problem. How can they fix their work? What did they neglect to do?
I think they have to take x minus 9. Then
Yes.
see x squared minus 4.
Yes. Okay, Jose, hold that thought right there. Do you see what Jose just said? She recognized that in this step, they forgot to write it in factored form. They totally forgot. So they went through the process of factoring by grouping, but they only went halfway, which is a huge problem. So Jose says, well, if we're going to fix this, bring the x minus 9 as your GCF, and then you have the x squared minus 4. So in which case, what would our next step be?
Set them each to 0.
Yeah,
equal 0?
you're very close. Now, Dimitri, actually that will work as
Oh.
soon as we learn about the square root property. But there's one tiny thing we should do first.
You gotta factor or whatever the last.
The last
Yeah.
Yes, trust yourself.
X
You're doing the
minus
right
2.
word. Say it, Jose.
X minus 2 and x
Plus 2. Yes, perfect. Exactly. Both of you are correct. Dimitri, when you said you've got to factor that x squared minus 4, you're totally right. Now that we've actually have it factored, that's when we can solve. And by the way, when we solve, x will be equal to 9, +2, and -2, which just supports the fact that, hey, you should only have 3 answers here. That's the proper procedure. So this is not good. Excellent work. Excellent, excellent, excellent work. Okay, now I don't want to freak you out at all because these are actually not bad. They're just a bunch of fractions first. Back in 098, when we had equations that had a whole bunch of fractions, do you remember what strategy we used to help kind of move through that? Because we weren't really fans of fractions, but we were able to fix it. How?
I think we clear them by finding the LCD.
Yes, you clear them by finding the LCD. Once you take that LCD, multiply every term in the equation by it. So what I'm actually going to do with you on this page is I'm going to set you up, and I would like you to finish these on your own, and then we'll reconvene and see how you did. But let me set you up. Let's take a look. So for part E, notice that I only have one denominator, it's 2. Someone shout out, how many terms do I have in this equation right now?
3.
Yes, I have 3. Your first term is 1/2 x squared. Your second term is a positive 8. Your third term is a 5x. Well, I don't want to have fractions. I've never factored fractions, right? I don't want it. So because we have an equation, this is what allows us to multiply by the same quantity. Remember that rule. If you want to multiply by some sort of quantity, you have to do that to every term in the equation. You can't pick and choose. Right away, when we take 2 and we multiply it by 1/2, we see that they're going to cancel, which is super awesome. That leaves us with 1x squared plus 2 times 8, which is 16, is equal to 5x times 2, which is 10x. And I'm going to leave you right here. So I want you to solve this particular problem, but not yet, because I want to finish clearing F and G for you. Okay, you're going to take these home and play around with them. Let's look at part F. Okay, what do you think is your GCF in this case?
Two.
2 will actually only clear one of these because it's not big enough to take care of all of them. So you want to go way bigger.
12.
12 will definitely work. 12 is your LCD in this case. So we are going to multiply every term.
Did you just say GCF to trip us up, or did you?
Oh my God, did I say GCF? I'm so sorry.
Yeah, you did.
Your LCD is 12. So we're going to multiply every term by 12. When you multiply by 12, be careful. When you multiply by any LCD, be very careful. We have to look at each term separately. So check this out. Do you see for the first one that we can reduce, right? 6 goes into 12 twice. So that means it leaves you with 2 times 1x squared, which is just 2x squared. So there's your first term. For your second term, do you see that the 4 goes into the 12? So 4 goes into 12 3 times. And notice what you're left with. Sorry that it's stacked like this, but we're left with minus, and this reads 3 times 3x. 3 times 3x is a 9x. What happens in this last one?
The 2 will go in there 6, and then you multiply the 6 with the 3 and come up with the 18.
Perfection. Beautiful. At this point, you know exactly what you have to do. Okay, so we're going to pause on F as well. Don't solve this yet. You'll take this home with you. We have one more. Take a moment to clear fractions for part G. Take 30 seconds. Don't overthink it. What's your LCD? Multiply every term by it. Write down what you have left. Tiana, in this case, what's your LCD?
This I don't know.
What is your denominator?
4.
Yes, that's your LCD. That's okay too. Even if like you're looking at the 81 and you're thinking, well, 4 and 81, they don't have anything in common. That's totally okay, because really your only goal here is to cancel fractions. And in order to do that, you just want to find your denominator, right? In this case, we only have that one denominator here. So if we wanted to cancel that out, no big deal. You still have to multiply every term by that LCD, which happens to be 4, because there is no other LCD besides a 1. Everywhere else, it's just a 1. So that leaves us with 4x squared. Notice these 4s are going to cancel, so it's minus 81. And then, of course, 0 times 4 is 0. And then you're set up to actually solve. Very nice. Okay, you'll take these home, you'll try these out, and we'll see if you get the correct solution set. So we're going to verify that tomorrow. All right, cool. We are ready to get into solving formulas for a variable. Please don't panic. We've seen this last semester. It's just a continuation of that. But of course, we're in Math 104, so we're going to get a little bit fancy with it. But it's always the same stuff. So for instance, the opposite of addition is subtraction. The opposite of multiplication is division, right? When you solve for a variable, no matter what, whenever you go ahead and you solve, you're always saying, how do I get it by itself? How do I get this variable alone so that I can actually have a solution, right? As mathematicians, that's what we're looking for, a solution. So as we solve these, we always want to do the opposite operation to move a term or part of a term to the opposite side of the equals. So think opposite operations always, okay? We are going to get a little fancy with it. It's going to be something you've never seen before, which is cool though. I always like unveiling that kind of stuff because it's really, really cool. All right, let's take a look at part A. I'll just show you exactly how to do it. No big deal. So we have ax plus by is equal to c. Yes, I know there are no numbers. Not a big deal. We need to solve for y. I want you to consider that y is in this term and this term alone. It doesn't exist anywhere else except for that term. So the term that I highlighted has to be alone, which means ax has got to go. Your first term, ax, is positive. The only way to move a term is by adding it or subtracting it. I'm going to say that again. We move terms by adding or subtracting it. Nothing else. We add or subtract it because we're looking for the opposite. We're looking for the additive inverse. Inverses cancel each other out. Additive inverses specifically leave you with 0, which is great because we want to move it from one side so that it's 0 on one side and it goes to the other. So we're going to start by subtracting ax. What you do to the left side of the equals, you do to the right. Notice how I brought that over. Notice ax minus ax, well, those are opposites, so they completely eliminate each other. It leaves you with a 0. But because we're bringing down by, 0 plus by is still just by. Now notice we have from top to bottom c minus ax. So we're going to write that exactly as we see it. I know last semester I really preferred that you would write it in descending order. It's not a big deal. We're starting to become much more proficient in the math that we do. So I'm not worried about the order here. Last step, I need to get y by itself. Think about how y is connected to b. This says b times y. Nothing else. This does not say b plus y. This does not say b minus y. This also doesn't say b divided by y. When they're connected like this with no operation in between, we know it's a multiplication, which means the opposite operation is division. You are going to divide every term by the same quantity. So our final answer becomes y is equal to c over b minus ax over b. If we could reduce either fraction, we would, but there are no common factors, so we're done.
Quick question.
Yeah.
Would it be wrong to write it like y equals c minus ax all over b? Or is it
Not at all.
Okay.
Beautiful. So I'll write it as both ways. The only caveat to that is be careful, because if, let's say, when you split them up, you were able to reduce, you have to. Okay, so if you left it as one big fraction, actually, I'm going to show you an example. Let's say that you did the work and you had c minus ax all over c, right? That's actually not a complete answer because you can actually reduce. Please don't just cancel those out and call it a day. That's not cool. It's not how you do it. What you'll end up having to do first is rewrite it as two separate terms. So c over c minus ax over c. And then you would say, oh, c divided by c is 1. And then that would be your final answer. So do you see how you would have to progress through this kind of a problem? Which is why it's so helpful to see it as two separate fractions, just in case you have to simplify the fraction itself. Okay?
Yeah, that makes sense.
Score. But otherwise, yeah, if you know nothing's going to reduce, then yeah, that's totally cool. No big deal. Take a look at B. So I'm going to just rewrite this for a second. We have S, capital S, is equal to capital C over 1 minus lowercase r. Okay, we want to solve for r, but there it is in the denominator, right? The big thing I want you all to consider is we have fractions, right? We have a fraction. We cannot ignore that. So we have a couple ways to approach a problem like this. Let's recall the following piece of information. Let's say that I give you this. How would you solve this particular equation? And actually, let's just make it a little bit different. How would I solve that equation?
Come up with the LCD.
Yes, we can definitely multiply both sides by the LCD. So check this out. Our LCD would be 12. And we go through this process. We say that becomes a 3. So we have 3x equals the 12's cancel, 19. And then you solve and you get that x is equal to 19 over 3. I'm going to rewrite this problem. And I would like another approach. How else can I solve this?
You could
It's pulling from something very specific that we learned a long time ago. This has a very specific name. This setup right here has a very specific name. It starts with a P. Does anyone remember what this is called, this equation? It starts with a P.
proportion.
Yes, a proportion. This is a proportion. Well, we solve proportions by simply cross multiplying. Remember that? So we would do x times 12, which is 12x. And then 4 times 19, which is 76. And then, of course, we'd say, okay, I could just solve by dividing by 12. And you're probably thinking, that seems pretty different. But if you take the 76 and reduce it with the 12, you're going to divide both by 4. It ends up reducing to 19 over 3, which is cool. So you get the same answer either way. So what I'm trying to hint at with showing you these two approaches is that for a problem like this, you could really take either approach. You could write this s over 1 and then cross multiply it. Or you can multiply each side by the LCD, which is 1 minus r. So that completely is up to you which approach you decide to take. Okay, so that's totally up to you. Just for the sake of being different, I'm going to go ahead and use the property of proportions, and I'm going to cross multiply. Okay, so what this leaves me with is S times 1 minus r is equal to 1 times c, which is c. Now, some of you will distribute, and that's okay. I am not going to do that. I'm not going to distribute the s because I don't give a crap about the s. What I'm trying to solve for is r, which means s has just got to go. I just got to get rid of it. It doesn't need to be involved any further. So notice here it says s times 1 minus r. So if I wanted to get rid of s, I'm just going to divide it. That's the opposite of multiplication. So just by dividing by that s, I've opened up 1 minus r. So I have 1 minus r is equal to c over s. I'm going to highlight r again because my goal is to get it by itself. On the same side as r, we have a 1. How do I get rid of this 1?
Subtract.
Subtract. So now I have negative r is equal to c over s minus 1. But I'm still not done. I want r to be positive, right? One of the things we learned from my class last semester is that if we have a negative variable and we want it to be positive, we're going to imagine multiplying every term by a negative 1. What that ends up doing is it ends up flipping each of the signs for each term. So if I multiply by negative 1 times negative r is positive r. Negative 1 times c over s is negative c over s. Negative 1 times negative 1 is positive 1, and there's your final answer.
Could you have just subtracted c minus or c over s? Wait, sorry, never mind, because there would have been nothing on that.
Right,
Side, right?
exactly. And remember, your goal is to isolate this particular variable. So you want what's attached to it to go away. And that's why we subtract that 1. Get rid of that 1. And then bam, now we have negative r, but that's okay. We either multiply each term by a negative 1, or we essentially just flip all the signs. Boom, 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 done. Okay. So A and B are essentially similar to what we looked at last semester. Part C is the fancy one. This is probably going to end up being our last problem of the day. So part C is our fancy one. Right away, take a look. It says solve for C. We have P minus C is equal to MC. What do you notice? What's jumping out at you?
There's 2c.
Yes, interesting. Interesting. When you think of something like that, and you see that C is in 2 separate terms, would you agree that maybe it's going to be beneficial to put them on the same side? Let's do that. I already have MC on the right. Why not bring the other C over, just so that they're together? You want them to be together first, and then we'll talk about how we would take our next step. So I'm actually going to bring this C over. We want the C's together. Okay, we want the C's together. So that means we're left with P is equal to MC plus C. Wow, this is interesting because we just want C alone, but we can't right now because C is in two terms. I wonder what technique we could use that would pull this C out. What word am I looking for that would pull this C out of both terms? We are going to
Subtract.
no, not subtract.
Divide?
No, it's kind of like division. It starts with an F. It's what we've been doing this entire time. Factor. We're going to factor. Do you see I have a GCF? Ooh, this is where we get fancy with it. This is something we haven't done yet. This is totally new. So we see that we have a GCF. If I factor out a C from both terms, what's left?
M.
M.
This one.
Yes. If I factor that C out, I'm left with M plus 1. That's interesting. CM or MC plus C. Okay, it works. We still have the equal to P. But remember, my goal is to get C alone. Recognize here, C is attached to the M plus 1 by multiplication. So we're going to use the opposite operation, which is to divide. Check this out. If I want C alone, I'm going to divide by M plus 1. Notice the M plus 1s completely cancel because they're identical. It's C times this quantity. So we're allowed to divide by that quantity. What you do to one side, you do to the other. And voila, our final answer is C is equal to P over M plus 1. Factor. So that's the technique that we end up using in Math 104 that we have not seen before. It's that you may have to combine the terms with the same variable, and then you'll have to factor the GCF, right, which ends up being that variable, just so that you can divide and get it by itself. All right. I hope that made a ton of sense. That is the goal, right? To make sure that everything is broken down in a way that is completely logical. I want this to be as logical as humanly possible. Remember, make sure you're practicing your homework. That first assignment is due tonight by midnight, and then the U substitution is due by Friday. Before you leave, I still have like 30 seconds with you. I do want to point out that by tomorrow's class, we will definitely be done with Unit 1. So make sure you print Unit 2 because we're going to start them tomorrow. In terms of your homework, you will then have solving polynomials by factoring, solving linear equations, and then of course this one. So I'm actually going to, if it's okay with you guys, I want these two due by Friday and this one due by next week. Is that okay?
Sure.
Okay, so we'll have this due by this Friday, which is the 11th. Same thing with that. Solve literal equations due by this Friday. And then I want to assign your last homework to next week. What day next week can this assignment be due?
Wednesday.
Wednesday. So as long as we do, let's do Wednesday. So that's the 16th. I would also like to just make your comprehension check due the same day. So your comprehension check will open up tomorrow. And I'll have this due by next Wednesday, the 16th. You have 5 attempts on this comprehension check. There are only 10 questions. That's it. It's a quiz, but there are only 10 questions. And you have 5 attempts to get as high a score as possible. It'll keep your highest. Any questions for me before we depart?
Page 18, are we done with that?
Page 18.
Page 18, do we have to do something?
For 18, I would love for you to solve those and find the solution for each of those. So actually, looking at those really quickly, you'll probably be done with that page in like 10 minutes or less. So I would say give those a shot, finish those. We'll take a sneak peek first thing tomorrow, okay? And James, can you actually remind me of that first thing, like page 18? Let's look at it real quick. Okay, awesome, thank you. All right, everyone, enjoy the rest of your day. I will see you mañana. Bye.
Thank you.
You're
Thank
welcome.
you. Bye.
You're welcome. See ya.